but I have to dash
You
down.
didn't tell me that.
No, I just forgot to tell you that. Yeah.
What happens when two black holes collide?
You get a bigger black hole.
You get a big black hole is one possibility, which I think the mass, it depends on what the black holes are doing, I believe.
It's never been observed. It's thought to happen. So since every galaxy has a black hole in the middle of it, and we know that one of the ways you get bigger galaxies is by merging galaxies together, then presumably the galaxies merge together, their black holes then spiral into the center, and they end up merging to form a bigger black hole. So probably whenever two galaxies merge, you end up ultimately merging two black holes together.
If they come together relatively slowly, then they can sort of merge together, and you'll create a big black hole that's got a mass which is actually less than the sum of the two masses, because it releases energy.
We've never seen it directly. There are actually experiments underway now to try and detect it, because one of the things that happens is when two black holes are in that kind of final phase of spiraling in together, they actually end up giving away a lot of their energy as things called gravitational waves. And so if you have a gravitational wave detector, one of the strong signals that those gravitational wave detectors are likely to detect is the inspiraling of black holes just as they merge together to form a bigger black hole. So within the next 20 or 30 years, hopefully this is something that we will witness directly.
But many black holes are spinning, and some of them, the supermassive black holes in the centers of galaxies, are spinning really, really quickly. So I've heard of some simulations which are, modeling galaxies colliding, and then of course they've got these supermassive black holes, millions of times the mass of the sun, hundreds of millions of times with some of them, spinning really rapidly. And the simulations suggest that actually what can happen is that they're both spinning, and it's like spinning tops coming, and they can actually bang together, and one can be bounced out, just totally out of the system altogether, leaving you with this big one. So it doesn't look like they always merge, and often they can go out. So I think it depends on what's actually happening to the black holes themselves as to what the fate of it will be.
So one of the amazing things about this is if one of these pairs of massive black holes merges together anywhere in the universe pretty much, then the kind of detectors they're building now will actually be able to detect it. So we'll be able to see this phenomenon right across the universe. So even if it only happens very rarely, if it happens anywhere in the universe, we'll actually see it happening.
Are you someone who can discuss and enjoy the beauty of a sunset, or are you someone who'll take all that time thinking about the atmospheric effect on sun rays and things like that?
I'm thinking about the science behind it, but that's making me enjoy it even more. The universe is a pretty amazing place, and it's even more amazing when you understand what's going on, or a bit of what's going on behind it.
Oh, you would, of course you enjoy them, but you enjoy them more. I spend all my time looking at this elusive green flash. Every time I see a sunset with a distant horizon, I always look, and some people who I respect tell me that it's there. It's some kind of visual optical effect. Perhaps in our eyes rather, or the way our brain processes light. But I've always looked for this, and I've never found it. But of course scientists like real sunsets and sunsets in the paintings of Claude Lorraine. Tremendous, yeah. Perhaps Claude Lorraine's sunsets are even better than natural ones.
We just had just been on holiday to southwest of France, and we were in a really rural place with some friends who came out and just asked me to come outside one evening with them, and there was the Milky Way. I mean, the real Milky Way, right? The one where you see the band going straight across the sky. Unfortunately, even though we live in a fairly rural place here, there's still obviously too much light to spot that. But this was just a band of light going across. And I didn't spend my time thinking, well, how many can I see? How many stars are in there? And how are those stars forming? I just thought, wow, that's bloody amazing, that. It was really neat.
I don't think that explaining the details of how it works takes away from its beauty at all. So they're completely continuous.
Now I will look at the sunset and take photographs of it and say how beautiful it is, and my wife will drag me to see the moonlight and everything like that, and you can enjoy it.
I guess I would flatter myself to say that I can do both at once. That actually, because people kind of think, well, when you understand the science of something, that somehow detracts from the beauty of it. I don't think it does. I can, both appreciate the beauty of a rainbow, say, and actually enjoy the fact that I understand why it's there. And I don't think there's really any paradox, any contradiction between doing both at the same time.
I think one of the things that Feynman says, and which is, I think, so true. One of the perhaps advantages that people like myself who work in this area have is that not only can I love the beauty of it for its own sake, but then I can actually begin to think about the beauty of the mathematics that describes it. And so there's an additional beauty, if you like, which adds on to it. It doesn't take away from the beauty.
You know, again, coming back to Feynman, you know, the fact that you look at that sunset and you think about, well, how is the light scattered and how the physics of that doesn't diminish from the beauty of that sunset. In fact, it increases the beauty of that sunset.
Is that what you say to your wife when she says, "Do you think I'm beautiful?"
I perhaps wouldn't put it in those terms, no. But that's another thing, you know, you know, my wife, my children, I love dearly, to, you know, to use that cliche with all my heart and soul. But the fact, you know, that you can also consider love and emotions, or think about love and emotions philosophically in terms of biochemical pathways or whatever, it doesn't diminish that love. So,
I mean, you might understand where the moonlight is coming from and where all the different patterns in the sky are coming from, and you get a certain joy from understanding where a rainbow comes from, or any of these other things. But the aesthetic sense, the sense that the world is a beautiful place to live in, the rest of the universe is hostile, but the earth is wonderful and it ought to be preserved. And you see nature and dragonflies and all sorts of other things in your garden. That's just wonderful. But that must be true of everybody, surely. I see the same sunsets and rainbows as everybody else.